All right, so welcome to session 1168 and the infrastructure track. We're going to go through a couple of things really quick for some introductions. This is a panel session, so there's going to be some interaction between our three panelists who are going to introduce themselves. First thing is the typical VMware disclaimer that we all say, take a look at it, print it, skip it. Okay. Moving on, so the agenda, we're going to go through some quick intros. And what we're going to talk about here is really how to architect a cloud, and not technically architecting it, but looking at things like the requirements, your sizing, your scaling, how you're going to deal with your host design, your vCenter designs, cluster designs. The point of a session like this is to help you guys start to think a little bit more, right? To actually think about what you're going to do when you go out and you design cloud. Now that we announced the vCloud suite, right? Everybody saw that this morning, right? So some of this stuff should help you walk away with a little more understanding of how these guys and myself will actually design a cloud for customers, consumers, service providers, you name it. So first, my name is Chris Colotti, so I'm a consulting architect in what's known as the Global Center of Excellence inside VMware. VCDX number 37, my blog site, and you can follow me on Twitter, and then we'll just kind of go down the line here.
Yeah, Aidan Dalgleish, I work.
Oh, you need the microphone.
Yeah. Aidan Dalgleish, I work for the Center of Excellence like Chris Colotti, and VCDX number 10, and my blog site's not up and running yet, so you'll have to wait a while for that.
My name is Rawlinson Rivera. I work for the Cloud Infrastructure Management team in PSO. I'm VCDX number 86. My blog is Punching Clouds, and you can follow me on Twitter and Punching Clouds.
Hi, my name is Duncan Epping, VCDX 007, so I guess I got the coolest number of these guys. My website is yellowbricks.com, and you can follow me on Twitter at DuncanYB.
Excellent. So moving right into this. So what really is this session about? I mentioned that a little bit, but we're going to talking about a cloud infrastructure management white paper that was published a while back. It's not meant to be a blueprint, right? You don't want to take this thing away and go start building, right? That's not what this is for. This is really for you to understand how you would modify and make decisions, because designing a cloud is really about making decisions to the architecture to meet the customer's requirements. We'll talk about those design decisions. We've actually got a few real-world, examples is where these decisions were placed. We'll talk about some pitfalls, right? Where these guys and myself were always really good about making sure we let you guys know where some of the speed bumps might be, right? If we don't do that, then we don't want you getting caught. You can tweet and blog about these sessions. So there's a little bit of a change with the Twitter streams this year. They're asking us to use VMworld INF, which is the track that we're under. For us personally, if you'd like to use both hashtags, that and the VSP1168, it'll help the four of us filter a little bit. So just put both of those hashtags in there, and we'll make everybody happy. Take pictures, tweet them. We all need some new ones, I guess, for our avatars. Aidan needs one, I think, period. So best picture, Duncan's going to give away a free copy of the vSphereAI clustering deep dive, right? Autographed, not autographed?
Autographed.
Autographed, okay, perfect. So the first thing we're going to talk about in architecting a cloud, and we're going to basically let these guys talk about it amongst themselves, and that's how the slides are going to go a little bit, and then you'll have the takeaways in each of these. And so, guys, let's talk a little bit about which of the requirements gathering you do the most, which ones are important, and some of the critical things that you want to talk to folks about.
So one of the key things that we do, and we need to do always whenever we're trying to architect a cloud, is focus on what you're trying to achieve. Before we kind of get into the technology, let's find out what is it that we're trying to solve first, and then we can kind of derive to some sort of solution on what we're going to use, right? So it's not just about the tools can do this, the tools can do that, that's what I want, but it's not really to that point. What is it? How are you going to make it work for you? What is it that we're really trying to solve? So one of the most important things that have to happen in an engagement for cloud architecture is that we basically have to identify what are the actual requirements that fit into that solution that you're trying to achieve. A lot of times we find that you are aware of the technology and some of the things that the technology is doing, but it doesn't mean because that's there you need to throw that into the whole equation, right? Maybe one of these components or one of these things that you're trying to achieve may not play well with exactly what you're trying to do, right? We're not talking about feature rich, we're talking about what is it that you're trying to do, which is very, very important when it comes to architecting something like this. When you get into cloud architecture, it's a really, really necessary thing that you understand that doing cloud and what we do now, it's not just a matter of just a technology. We're addressing a business case. You're about to streamline a solution. You're about to do something that makes something more efficient, right? Let's go after that point before we start sort of picking out what sort of technology you're going to use. So requirements, it's a big key here. So whenever you're looking at what is it that I'm trying to do, what's the requirement for that? Let me give you an example. What are you trying to solve in your environment with your cloud? Are you trying to achieve some sort of fast provision, increasing agility of your environment? What plays into that requirement from a very core perspective? Not just, I know I can do things by template or things like that. It's not about that, because there are multiple ways of doing things. It's just a matter of being able to achieve what is a requirement to your cloud design and your architecture than more there is a more of achieving some sort of feature solution that's within the product itself. So again, I could not iterate more that one of the biggest things when it comes to this is having to be able to understand what you're trying to achieve. There's also a place where it would be nice to have some things, but what are the actual goals? What are the drivers for what you're trying to get at, which are not always based on the technology. We'll get there somehow. You'll have everything that you need, but it's always more about, how do I get there? What is it that I'm trying to do? So when it comes to, for example, some of the VCDXs that are in the panel and some of the guys in the field, we take this approach where we know we have a lot of technology. We know we have what you need, but how do we use it? What's the point? It's not about, I want to give you all these features, but really how do they play into your operation through your streamlining of the solution you're trying to implement? There's a lot of things here, and they will only play well if you have well-defined requirements and you have a goal on what you're trying to do.
Yeah, so there's really three things that we want to touch on, right? There's, and we'll let Aidan and Duncan as well chime in, but there's three areas, right? Requirements, constraints,
and assumptions.
Right, those are the three big things that all of us run under. So, we'll go through some of the examples. Some of the examples of the requirements that Rawlinson spoke about is up on the screen. So these will definitely be available for you, and we put the examples together so you can think about these when you walk away with your customers.
Let me summarize what Rawlinson just explained in a couple of simple words. Key thing here is talk to your customer, right? And I know that might scare some of you. It scared me as well, and I try to avoid doing that. But you really need to talk to your customer, because he's the one who actually knows what needs to be implemented, why he's doing it. That's the key thing here.
Yeah, you don't want to do this in a bubble, right? You have to actually ask some questions, listen for some answers.
And we've seen that happening as well. So.
Yeah. So let's go through a couple of example constraints and assumptions as well. So what are some of those, I think, Aidan?
Okay, so typically what I tend to find is constraints-wise, it's pretty much always hardware related. So a customer's got a given storage array, they've got given models of server, and that's pretty much a given at the start of any engagement. That's something you've got to work with. So, but don't always look at that as a negative and assume you have to take that as is. Talk to your customers again. If you need additional network cards, ask if there's an opportunity to procure those. And if you need that for your design, ask. Okay. Storage, again, it's typically there. That's not normally something that they're going to put a new storage array in for your design. But in some cases, if it's needed, it's a requirement, and if the hardware doesn't meet the requirements that have been defined, they've got two choices. You either review the requirements and reduce them, or you have to procure more kit.
So assumptions are usually the necessary evil, right? They can be dangerous. They can be things that we have to do. So where do we actually make these assumptions? Why would we make an assumption?
Well, you start thinking about what's available to you, and you would say, okay, so if I'm going to deploy X type of environment with X amount of capacity, I'm going to assume that there's some sort of infrastructure in place, there's some sort of capacity from a network perspective, whether it be a storage perspective, whether it be a compute perspective, where you think it's there, but really ask for it. Whatever you remember, there's a saying that says, if you assume, you're going to look like you know what. So you might as well ask the question so that you don't look like that at some point. And it becomes very useful to that point, because then you do not want to have something that you can change or something you weren't able to achieve with a specific design.
So once we've actually...
Hold on. I still see a lot of people standing up. There's a whole bunch of seats available
right
here in the front, so feel free to come up, guys.
Thanks. So once we've actually gathered some of these basic requirements and assumptions and constraints, what do we need to look at from some things of historical issues, use cases, and things beyond that approach. What's after we gather that?
Okay, so before kind of diving into a couple of myths around some of the best practices, what I wanted to do is kind of summarize one of my kind of key views on this is, don't assume a best practice is right for your scenario. Okay, a best practice is there as an example of the best way to do something in a given scenario. That may not be the same as the infrastructure you're trying to deploy. So by all means, challenge a best practice. And the key thing I'd recommend is read it, understand that best practice, and then ask yourself, does that fit and does that apply to my scenario? And this is without wanting to reference too much back to the kind of the VCDX side of things, this is a key thing we do and we look for. Don't blindly trust a best practice because it may not fit for your scenario. Prime example that's been a pet hate of mine for many years is the example of a 500 gig LUN is the best size and you should only have 15 VMs per LUN. If 5 of my 15 VMs require 2,000 IOPS, how likely is that going to be met with a bog standard kind of RAID 5 LUN? Probably not very well.
Yes. So how many people still use that best practice?
So how many people are doing 500 gig LUNs right now?
Be honest. Come on.
There's probably more than this, I bet you. So another one, for instance, is cluster sizing. If you look at cluster sizing, historically speaking, people have been doing 8-host clusters since the 3.0 days. So who does 8-host clusters today? That's still a couple. So you'll see, for instance, with vSphere 5.0, that most of the constraints that we had around that have actually been lifted. But out in the field, we still see people deploying it just because of the fact that it was documented as a best practice in the 3.0 days. So as soon as you start creating your design, make sure you revise those best practices as well, right? Because they change.
Yeah, tying into that example, think about the view issue, right? So that was a constraint. So that constraint would drive an 8-host design, right? So you have to tie these things together in some ways too.
Also, in some of your cloud environments, depending on the type of storage and provisioning process you're trying to achieve and do, may have a limitation on how you want to achieve some of these things, right? Where you may have to use it at a certain size because according to what we currently support on the platforms, it's not there yet. But you have to understand that you have to know what's going to be in play here so that you can actually make those right decisions.
So when Chris just mentioned the view issue, does anyone know what he's referring to?
Oh, sorry.
That's what I was guessing. So there's just a couple of guys who knows what he's referring to. So what Chris was referring to was the fact that you can only access a shared file on a VMware data store with 8 hosts at the same time. Meaning that so if you were using link clones, for instance, then you can only have 8 hosts in this cluster because 8 hosts can only open up that file at the same time. Now it's good to know that with 5.1, this constraint has been lifted as well. So in VCD environments and view environments, as soon as we start supporting that, you can actually go up to 16, 24, or 32 nodes in a single cluster if you would like to.
So what about some use cases that you have to look at during your design process as well?
So to kind of lead into this whole thing that Duncan just mentioned too, so some of the use cases, you want to have different tiers of storage. You want to have different types of offerings you may have within the storage side. You may want to have an environment like we just said. It might be dependent on using View if once it's supported, or any way you might have going that way, whether it has to do with capacity planning, the way you architect or scale out or up. So these are some of these scenarios where you can actually look into before you define or decide which way you want to go with your architecture and your design.
So if you look at the, can you go back, Chris? So if you look at the diagram on the right, I think one thing that stands out to me is the application, which is centric in this diagram, right? I think that's something that a lot of people actually tend to forget. As infrastructure architectures, you actually focus on the virtual machines and on the infrastructure layer. Well, for your business, it's only the application that really matters. So if the architecture and your infrastructure doesn't scale according to the requirements of your applications, then your customer will not be happy. And that's key thing to remember here.
So once we've continued down this process, right, this whole designing of the cloud is we're presenting this to you as a process, right? So we have to actually do some conceptualization, right? We have to take all this information, all this data gathering, and figure out what's next, right? So can you talk a little bit about that, Duncan?
Yeah. First, a question. So, how many people actually add a conceptual diagram to their architecture documents? That's good to know. Because what I've seen in the past is that a lot of people actually didn't do this, and I actually started adding those explicitly for management, right? Because talking with an admin, a sysadmin, an architect, they understand where you're coming from. So they get the logical approach, they get the physical approach. But a manager usually doesn't go to that level of depth. So as soon as you start adding conceptual diagrams, it actually gets clear to them what the point is of your architecture.
So Duncan explained this to me once as treating it like a storyboard, right? You know, so when you watch, anybody who's watched the history of making movies, right? All things start out as a rough sketch, right? Everything's that back of a napkin, and our famous back of a napkin story was our cloud DR, right? And we had this conceptual diagram literally on the back of a napkin in a Marriott, and then we turned it into something. So scaling, an interesting announcement today, if everybody watched Steve Herod's video, the monster VM sizes, right? Did anybody pick up on that new number? 64. What was the one on the bottom, though? Million IOPS at the VM level, right? So scaling and sizing is always going to be an interesting... What's that? Who has requirements for a million IOPS in a VM? I want to know, because Duncan and I and everybody up here would like to go work on that project.
That's a very juiced up app.
Yeah, that's an app on steroids. So let's talk a little bit. This is always where there's a lot of contention, right? We talk about sizing. How do we size VMs? Are they oversized? Are they undersized? How do we size the host? So there's a lot of components to sizing. So let's talk first a little bit about some of the basic details, and we'll walk through some tools and how we get into network and storage and the other components, right? So we'll walk through the stack. So Aidan, first, can you talk a little bit about the basic details?
Sure. Okay, so one of the fundamental aspects is going to be your sites and your locations, and this is going to refer back to your use case. If you're working purely on a consolidation exercise, then maybe you actually want to consolidate multiple sites down into maybe one or two. If your use case and your requirement requires DR, then definitely you probably want to maintain those multiple sites. How does this impact your design? And in terms of identifying and measuring your candidates, a good thing I always tend to do is, like we used to do in the good old days of virtualization assessments, is identify the low-hanging fruit. Why pile straight in and try and virtualize the hardest application there? Go for the easy one, realize the business benefits as fast as possible, and leave those harder, more trickier applications to virtualize towards the end. And again, to contradict that, the option might be that you have a very specific business requirement you need to meet, which means going straight for the hard one. What I tend to do is look at the use cases, and if you look across there like an 80-20 rule, most of them will kind of fit a common type of requirement, and you could probably pick out a small number of those use cases. So if I looked basically at memory requirements, I bet if I were to take the top 10 or top 20 VMs out of any virtualization assessment, that would significantly reduce my average requirement, because those few small VMs would be heavily skewing the results. Again, another one is review the scalability limits, right? We publish them, they're there in documentation, and the number of times that people blatantly ignore them is unreal. They're there for a reason, comply with them. It's pretty simple and a good rule and best practice.
So with that, actually, Duncan, can you talk a little bit about other tools, right? The sizing guides are one thing, and certainly the maximum sheet, right? How many people are familiar with the maximums sheet? And after today, how many people are going to want to go find the 5.1 maximum sheet? I don't know that's published yet, though. Can you talk about some of the other tools that's available to everybody here to use to help with their sizing?
Yeah, I guess first of all, for me, it usually starts out with Capacity Planner, and I think that's probably one of the tools I use the most. And it's one of the most valuable tools. Now, the thing is that, especially as a partner, as soon as you start running these capacity planning exercises, you will notice that the outcome usually looks the same. So every single one that I've did, they all have the same curve. Now, the funny thing is, after a while, you start wondering, why should I even look at this document, right? Because they're all exactly the same. Now, the thing is that what stands out for me is you need to look for those virtual machines that stand out. There's always a couple of virtual machines which drive an insane amount of IOPS. Those are the virtual machines that you need to take into account when you start scaling and sizing it, because they might need a raw device mapping, for instance, or they need a dedicated LAN. Or maybe they even need to be separated on a specific host. Other valuable stuff that you can get out of these tools are things like, is a serial port device used, or is there a USB key used, for instance, which might make it difficult to virtualize some of these devices.
So how many people are familiar with the capacity planner utility? Excellent. Perfect. That's a good amount. Awesome. So Rawlinson, talk a little bit about how when you're on site, you deal with compute and memory are probably the two things that most people get stuck on, probably more memory than anything, right? So talk a little bit about some of those considerations, please.
So one of the things that we experience in the field, we have certain recommendations when it comes to architecting cloud. We don't expect you to take your current infrastructure and on top of it deploy this new model of operating your environment. Now, how many of you have started a greenfield sort of, or not just greenfield, a new infrastructure for your cloud environment, right? And we encourage that because this changes a lot of things. Now, here's one of the biggest misconceptions that we have. A lot of times, when you have the capability of making the choice is okay, but basically, you normally go out there and get the largest piece of hardware you can and pack in as much memory and as much CPU powers as you can. When you look at the compute consideration, you get to a point when you start packing and stacking some of these systems, some of them go from a Ferrari to a Porsche to a Ford, whatever. It comes to a point where when you start looking at the ratio of utilization you're going to have between memory and CPU, it could either go up or down. But the problem is always going to be memory, right? Because we always somehow, we overallocate memory more than we do CPU. But you have to also be careful and understand exactly what are the applications trying to do. If you're going to have a processing, calculating sort of native nature of an application, it'll probably pull from one over the other. So being able to have the right ratio to memory, right amount of CPU, whether it's something that's provided by either one of the vendors, we don't really care. Understand your application. Understand that if there's something specifically to a feature set that it's enhanced in vSphere by any way, shape, or form, you have to understand what that is and get to those points. Sometimes it might be a system that may have X amount of gigahertz. The memory may be up to whatever 96 gigs of RAM, 126. Now we're saying we can have a VM that could do a million IOPS. How much memory does that take? What's the host that's going to support that? But when you get to that point, you have to basically understand on how that compute process is defined and allocated. Don't just go based on we can do this, we can do that. Remember that the more CPUs you give to a virtual machine is not always the better solution. So understanding that is it's a really good way to kind of get a good process on your design and your architectures.
And I think we might actually have a session on that this week a
yeah.
little bit.
So,
talking about allocation and okay. Just shameless plug.
Let me add a specific example as well when it comes to network or when it comes to memory, for instance. So one of the things that I noticed when I started doing deployments of 4.1 is that the memory consumption or the use of memory increased substantially. So I went up from 60% to 96%. No one understood what was happening. So in this case, we were starting to use 64-bit operating systems. And those 64-bit operating systems more or less forced the hypervisor to start doing large pages. Now, as soon as we started doing large pages, we weren't doing any transparent page sharing anymore, which meant that the use of memory went up, to my surprise. But it's something that stood out, and it took us a while before you realized why it happened. And we had to train our customer explicitly on that as well to make sure that they understood that we weren't actually consuming more memory. It was just a change in behavior of the vSphere layer. And we could actually revert that as well if you wanted. So there's a lot of options and a lot of stuff you need to take into mind.
So, and also understand that the more you add to any workload, the more the overhead will be, so that memory footprint just grows. And as you move further into your designs, that plays in a big deal, because when you start having things that are holding reservations for VMs, and you play into all the other features, HN, all that, there are things that are required, and it can prevent you from being able to boot up certain VMs. So being able to account and calculate compute resources, being able to do proper capacity planning is key. And I got to tell you, not everyone has a really well-defined capacity planning, whether it's on a spreadsheet, whether it's a tool, whatever it is. Capacity plays a really big role, specifically when it comes to cloud architectures.
So, Aidan, can you speak a little bit about networking? And because networking is always a tough one, I think, to size, even with some of the tools.
Sure. So, kind of referencing back to what Duncan said with a lot of the results we see in Capacity Planner, is typically networking bandwidth is never a bottleneck. Certainly in a lot of the designs I've done over the years, it's generally very low, down at a few megabits per second on average. And again, there'll be that top 10 or top 20 VMs in there, which are probably accounting for a large portion of that. So I generally don't worry too much about that. Now, obviously, if you introduce technologies such as FT, that can significantly increase the networking requirements. So, but out of curiosity, you know, how many people here are actually running FT in their environments for production?
I see 4.
Yeah. So, you know, generally, again, that doesn't typically come up because a lot of customers I've worked with, they've considered it too new a technology or too afraid to use it, or have used it in 1 or 2 use cases. And certainly, as we see with a lot of VMs today, they tend to be multiple CPU. Even a lot of our own VMware appliances and VMs now tend to be multiple CPU, and so we're pretty much automatically ruling out the use of FT, unfortunately. So generally, networking, that's kind of not an issue too much in terms of scale and sizing.
How many people like me in the past have always blamed the network? And what's the answer from the network guys? It's never the network, right? Until I found the one network guy, that it was the network.
And I guess just one more point to add to there is, in the rare case you do get a really network bandwidth hungry application, providing your availability options don't cause an issue, consider the use of putting those VMs onto the same host as well, so you're not then having to rely on the physical network as much.
So, Duncan, talk a little bit about storage sizing, because I think this one now, you know, as storage changes and continues to change, and some of the things we saw today, you know, there's always new considerations for that.
One thing to add is, I guess we always blame the network, but it's usually the storage which causes the issue. So, and that's where sizing.
We're going to make a lot of friends today.
Yeah, EMC is not going to be happy, and neither is NetApp. But so the one thing I want to point out, storage sizing is probably the most critical part of the design, in my opinion. If I look at all the health checks that I did, for instance, 90% of the problems that our customers were facing were caused to bad planning and designing around the storage. And it wasn't like they didn't want to do it, but it's fairly complicated when it comes to all the different types of storage arrays, different various array types that you have, and then doing the maths around the amount of IOPS that a single LAN can drive, the amount of virtual machines that you want to have running on those LANs, creating failure domains, things like that. So it's a fairly complex thing, and there are so many things to take into account. But the key things here are, A, do the math and get your storage partner involved with this. So I was making a joke around EMC and NetApp, but every single time that I ran into these issues, I sat down with those teams and made sure they understood what the workload was, right? Because they need to be aware of what's running on top of that. And based on that, you will need to do the math.
So can you talk a little bit about some of the actual considerations? I think, how many people actually design to IOPS for their VMs? It's a good question. How many people don't? You just stand up storage and throw virtual machines on it and hope for the best. Yeah.
Yeah, so like I said, some of the considerations would be, for instance, around the array type that you would be using. So as soon as you start using a specific array type, there's an overhead associated to array type. So if it's RAID 5, RAID 6, RAID 10, or RAID 1, there's an overhead associated to that. So there's a penalty, and that's due to the parity that needs to be written to the disk. So in some cases, a single IOPS might require 4 IOPS on the back end. So you can imagine that if you have 50 virtual machines running, driving just a couple of IOPS each, that could be 1,000 IOPS at the back end. So you need to make sure that you would actually meet those requirements for those virtual machines.
So one of the topics that always comes up, and this is interesting, is we don't design, we had this debate, right? We really don't design hosts now, right? With the advent of ESXI, there's really a stand it up, but there's a lot of considerations on configuring the hosts, I think, where we have a better conversation. We're not back in the old days of how many, how do we want to separate our volumes, and how do we want to partition Linux, and do all these things that we used to do back in the day. So Aidan, can you talk a little bit about what we consider with ESXi now, and some of those boot considerations, auto deploy, things that we have going on now?
So typically tying this back to the constraints again, most customers we come to, there's a host platform, that's been chosen, and that's what we're going to work with. As Chris mentioned, the option now is ESXi, and that's what we tend to deploy. So often we do have the choice of blade versus rack. So again, that's normally constrained by the customer's requirements. And we're looking at then kind of power considerations. And in terms of racks as well, traditionally a lot of people have a top of rack configuration. If you start going to a blade infrastructure, if you're using pass-through versus switched in the chassis, then again, I've had it with a lot of customers where, okay, we're pretty short on network ports here, and it kind of blows their whole top of rack model because they need 2 or 3 switches in there. So that's some of the kind of considerations from kind of the physical infrastructure. And then in case with ESXi, you've got the options of do we go with installable, do we go with embedded, and if we're using the installed version, we're going with local disk or SANLANs. So, embedded represents a good option. You've got the USB key, but typically if you're looking at a physical local disk, that tends to give you a better kind of reliability than a USB key. But again, there's a lot of people out there using USB and without issue.
So, Rawlinson, what have you run into in the field lately with actual boot options these days?
Let's see. So as we continue to advance, obviously there are now SSD cards that we install things, fairly much like USB keys. But the options become, there are few now. There are different ways of actually being out there. Now we have stateless capabilities. We have ways of being stateful. You can choose the media. There's a lot of different best practices depending on what the platform you're using, on how to go about your deployments based on that. They all work. The key is always, choose the way you want to do the deployment based on requirements, on facts. We're not talking technology, basically, in this point. Maybe it could be a process, that you're trying to optimize, streamline. Maybe the fact that you have to have validated configurations in a certain way to how things are done. Understand that depending on the type of installation and booting option you choose, and depending on your availability requirements and SLAs you may have to meet in the event of a failure, booting up a host, depending on your installation process you chose, may take a little longer, right? And you have to kind of consider that, but also there's an operational and validation process for that should drive and affect what decision is made in that. So in the field, it's a variety. People still do local hosts. Obviously, if you do a local disk, the manageability of that increases immensely because now you have everything in multiple servers depending on the size of the environment. But just kind of look into the details of that and what it takes and the effort in what you're actually trying to achieve out there. But everything is pretty much doable nowadays.
So how many folks have actually leveraged auto deploy since that was released? So not as many as I expect. So Duncan, I know when auto deploy first came out, you and Alan and a bunch of other guys did a lot of testing on this. So this is a good topic for you to touch on a little bit.
Well, let me ask another question first. How many people think auto deploy is really cool? So, and I guess one of the reasons a lot of people are a bit hesitant around deploying auto deploys itself, it's a new feature / product, right? So that also always imposes a challenge. On top of that, the availability of auto deploy, that has been a difficult discussion because there are so many dependencies within your infrastructure. Now, I think it's a really cool piece of technology, but I've always warned my customers and partners about the availability aspect of auto deploy, and mainly because of the fact that there are so many dependencies. So if you start deploying it, make sure that you actually are aware of what these dependencies are. So for instance, auto deploy heavily relies on vCenter server, of course, but there also needs to be a Pixie boot environment available. On top of that, you will require DHCP in the data center. Now, I guess that's the biggest pain point when it comes to deploying auto deploy. So I've seen service providers doing that. I've seen just 1 or 2 enterprise organizations doing that because that is the most difficult aspect, DHCP.
Excellent. So that's actually a good segue because vCenter is one of my favorite topics. It always has been. Actually, as a cloud guy, if anybody's heard me speak before, I always have a spin on the way I talk about Virtual Center these days and where it's kind of becoming the stack overall in the cloud stack as a more of an application layer. So Rawlinson, can you talk a little bit about, with knowing that and some of the things dependencies that Duncan's talking about, I think Virtual Center has become a dependency to a lot of components inside the vCloud suite that we talked about today.
So just as Chris mentioned, so we have, how many of you know about vCenter Heartbeat?
How many of you use vCenter Heartbeat?
How many of you are thinking about doing cloud deployments, like for real? How many of you do production and dev environments for cloud? Okay, so you know that your dev environment becomes a production environment immediately, right? Because everyone just needs it just as bad as the production. Well, think about this. Every component that's within the platform has a very, very heavily dependent on vCenter. So how do we make vCenter available so that if it's out, your cloud continues to work, right? That is the main... For one of the main CMDBs we have, the main repository for the main source of the information. Remember, with cloud, we introduce an abstraction layer, right, where it comes back to that. Now, how do we make that highly available? You have to take that into consideration, because if that piece is not available, you're going to have some issues for X amount of time, right? But you have to adhere to certain SLAs and certain things, agreements that you have to be to, right? So that tool provides you a certain level of capability, but it also protects you with other components as well. And in cloud, because all these things are kind of related to each other, it's important to understand that aspect. It's not about, yes, I can have a vCenter service on standby, and I can bring it up in X amount of time. The process is a little bit more intricate than just saying, let me just turn up this other VM databases and all that. So there's some process, there's manual procedures. You got to think of change control and all these things that we have to follow in the event that something goes wrong, right? Also think about, we now provide in the platform that you're able to, you don't have to put everything into the same vCenter server. We don't tell you package, update manager and all the other components into the same vCenter server. Take into consideration the size, but also take into consideration when you're going to put these plugins for your storage vendors, whatever storage you're using, right? Account for that. We have certain recommendations based on what you're going to have in terms of the environment. We provide 4-8 CPUs, X amount of memory, depending on the size of the environment. But we're specifically talking about what we're doing with vCenter, right? Every time you add another component on there, account for that, right? Think how things are going to go and how they're going to move, because it'll have an effect on the performance of actually vCenter and protecting as well.
So how many folks like me, again in the past, have a limited number of folks that access Virtual Center today, right? There's maybe a handful, small teams, right? So when Virtual Center goes down or has an issue today, it only affects those users, right? And what did we do? We lived with it for 10 minutes. We spun up another VM and pointed it to the database, installed Virtual Center, and all of us were back up and running. Well, to Rawlinson's point, in a cloud environment, you look at that vCloud suite, and I'm sure Duncan's going to touch on this as well, a lot of components are talking to that, right? So now there's consumers on the other side. There's people that are trying to do things, and vCenter is an intricate part of all that communication. So what affected 10 of us before could affect hundreds, right? So availability is very important. Duncan.
Yeah, when talking about availability, we're not only talking about HA or doing some sort of clustering form for vCenter, but we're also talking about the backup. So as soon as you start doing vCloud Director, one of the things that vCloud Director heavily relies on are resource pools. Now just imagine those resource pools are gone, right? It's going to be really difficult, A, to charge your customers, B, to actually get them up and running again. Because vCloud Director has something which we call the modev ID, and the modev ID is used by vCloud Director to actually figure out where the virtual machine resides. Now, if anything happens to your vCenter server, and it doesn't know which modev ID it needs to point to, it's not possible to power on those virtual machines anymore. Well, you can do that, but you will need to manually import all those virtual machines, and that can be a very painful process when we're talking about tens of thousands of virtual machines.
Duncan knows that's one of my favorite topics. Disaster recovery of the cloud. So Aidan, can you talk a little, so Rawlinson touched on a good point. I think as vCenter's kind of grown, we haven't stuffed everything into the same server, right? We see a lot of designs where we pull components out. Right now with vSphere 5 and 5.1, there's additional components, right? We've got the SSO option, we've got Update Manager, we've got all these pieces and parts. Can you talk a little bit about sizing some of those pieces, Aidan?
Sure. So again, like the scalability limitations, again, there's a lot of documentation out there in terms of sizing Update Manager databases and vCenter databases. So out of curiosity, from the audience, when you've deployed your vCenter servers, how many people have used the calculators online?
How many people know there are calculators online? Okay, there are calculators online.
Yeah. So, yeah, just to kind of add to what Chris has said there, if you go online on the website, there's typically an Excel spreadsheet available. It's there for vCenter and for Update Manager as well. So that will tell you, based on your statistics requirements, the size of your inventory. It's a pretty, not sophisticated, but a detailed calculator. And you put in all the details of your inventory, the number of VMs, the number of hosts, statistics levels, and it will come up with a size for you. So instantly you can size your database correctly. Equally, for Update Manager, it'll give you recommendations of whether Update Manager should be separated from vCenter or potentially held on the same host. Now, again, add a curiosity question. How many people run Update Manager on the same server as their vCenter? Okay, yeah.
That's pretty common.
Quite a high percentage. So, again, so that calculator will give you a recommendation as to whether it should be separate. I tend to keep it separate just for simplicity of kind of managing that environment, and if I want to do a change to my Update Manager environment, I don't have to impact vCenter at the same time. So that's just a personal preference, but it's something worth considering. Another sizing is, what I've tended to see recently is, quite a lot of the VMware products run Java processes. Okay, and years ago we had white papers released on the performance and especially ballooning with Java processes in place. But very rarely do I see people considering the use of a reservation in such cases. So if you've got an environment, there's potentially resource contention there, don't exclude the use of a reservation. By all means, consider it. But again, this comes back to best practice, right? Understand what the logic behind that best practice, review it. Does it apply to your situation? If it does, use it. If it doesn't, don't.
One more thing I want to add on the vCenter piece. So I've been to some of your sites. I've seen some of your guys. Some of you are my customers. I've been there, right? So I'm going to give you an example that happens in relation to vCenter. So some of you here, maybe even more than what I've seen so far, run really large environments. We're talking 20, 30,000 VMs. We can support a lot of VMs. You probably know the minimums and maximums for vCenter in terms of number of VMs and counts and things like that. But it's really important also when you're thinking about a design and architecture and the availability of that environment, you also may want to think about reducing the risk, reducing the fault domains. I know that from a business standpoint, there's something about you have to license something else, but what is the cost of your environment being down compared to another license for vCenter? You have one single vCenter instance to administer and control a catalog of 30,000 VMs. You have an outage at that vCenter. If it's not properly, I don't want to say backup, but it's not made highly available, not just HA or clustering, whatever it might be, but some of the other things we talked about. Performance comes into play. Some of you have experienced this. Right? It's not about one can do a lot, can handle a lot, but reduce the risk of a single failure in a single point domain. Being able to have multiple vCenter servers to manage and control X amount of VMs and environments, specifically in cloud. You don't have to have just one vCenter when it comes to vCloud in an environment that's like that. So take that into consideration, explore when it comes to reducing the risk to fault domains and things like that. It's very important.
So the next topic is, if anybody knows Duncan, is one of his favorite ones, talking about clustering. I think, anyway. It's one of the things you always like to touch on. So can you hit a little bit, for the sake of time, where we really start with our clustering designs? And we touched a little bit on earlier with the 8 hosts and other things, but can you hit a little bit deeper on that?
Yeah, I guess the first and foremost, talk to your customers. So what will they be using this infrastructure for, right? So in many cases, what I've seen is that people start mixing and matching. So you see I even see view environments running on top of regular vSphere workloads. Now, typically, this is not something you want to do because of the behavior of a view desktop or multiple view desktops, or if you're unfortunate, thousands of view desktops being newly instantiated and basically bombing your vCenter environment. And the same applies to vCloud Director, for instance. So if you have a specific use case for your environment, you might want to separate your clusters. So make sure you create a separate cluster for your view environment, but also create separate clusters for your VCD environments. And in the case of VCD, for instance, the reasons for having a separate management cluster would be that if anything happens, so if there's a denial of service attack, at least your management platform is going to be available. Now, next slide, please.
Yep.
So when it comes to design considerations around HA and DRS, there is of course a lot of things that will need to be taken into account. I can probably talk about an hour or 15 about that. We wrote 400 pages on the topic, so it's quite it's quite an extensive topic. But the key thing usually here is how many hosts will you start deploying, and if it's less than 24, why not go for a single cluster? I've seen people doing multiple clusters of 6 hosts just because they figured, it's easy to have small failure domains. It's easier to manage, but on the other hand, you increase the cost of your environment as well, because from an HA perspective, you will need to add in some level of resiliency. So in that 6-node cluster, you will take out 1 node for availability reasons. Now, if you have a single 24-node cluster, of course, you might take out 2 or 3 nodes. But when you have 6-node clusters, the overhead is quite substantial. So there's also a cost associated to that. Now, another thing I wanted to point out is that with a lot of new versions, things change. So from an HA perspective, we see a lot of people actually setting, for instance, advanced settings. Now, that the advanced setting was a best practice in 3.0 or 3.5 doesn't necessarily mean it's an advanced or a best practice that you should use in 5.0. A lot of the advanced settings were actually changed in 5.0, for instance, and they will keep on changing, so keep that in mind.
You actually hit some of those. Apologize. So, Aidan, networking-wise, we've announced a lot of new products in the last couple of years, primarily around the vShield line. How many of you guys use the vShield line of products? I won't ask about app and the edge and the different ones, but this is always a changing topic, right? As VDS has changed and Nexus 1000Vs come in, and of course the latest thing, everybody knows what happened last week, right? Closed the Nicira acquisition. So I'm sure networking is going to change again. So can you talk a little bit about some of the design considerations, and then we'll walk through a little bit on each of the vShield products.
Sure. Okay, so today we have pretty much kind of a number of different options available regarding virtual switches. We still have our standard switches available, and out of curiosity, how many people are running virtual machine traffic still out of standard switches versus distributed switches? Okay, not many, as I suspected.
Not as many as last year.
How many people are still running management traffic across the standard switch versus the distributed switch? Okay, so a higher percentage. So we have those 3 options available. Now, in the case of if we're looking at using vCloud Director or any kind of products along those lines, we're pretty much almost being pushed in the direction of the distributed switch. Yes, you can use the standard switch, but you're going down to then manual creation or automated creation if you're handy with scripting of port groups for port group back networking. So pretty much everybody I see today, customer-wise, is using distributed switches for virtual machine traffic. So that's kind of become the de facto choice. Now, there's obviously other choices such as Nexus. So out of curiosity, again, how many people are running Nexus in their environment? Okay, quite a few. Also, other requirements can be use of VLANs. So how many people here are running private VLANs? Quite a few. Okay, so one of the things that automatically forces you to use the distributed virtual switch or a Nexus over a standard switch. But of those people that use private VLANs today, how many considered the use of vShield app? Okay, so vShield app is potentially a very good use case for dealing with a private VLAN type, a use case of a multi-tenant backup network or a multi-tenant management network, and it's one I've been starting to discuss and explore a lot more with customers today. Not only is it purely a network, apply the technology in terms of a network, but you can apply policies to resource pools and port groups, so it kind of works very well and is very vSphere centric, and potentially, depending on your exact configuration, could offer more security than private VLANs in terms of not being subject to MAC spoofing or anything along those lines. So I guess the short of it is there's a lot of options there available with networking. If you've got private VLANs, you're pretty much forced down that route. Other ones to consider, jumbo frames. How many people are using jumbo frames? Okay. So traditionally, VMware's trying to recommended the use of jumbo frames where IP-based storage is in place. but more so with the introduction of vCloud Director, in particular vCDNI and VXLAN, where we have requirements for increased MTU, then again, jumbo frames is becoming recommended more often, or at least increasing that MTU. Have you guys got anything to
You can go.
Okay. So in the point also, you know, I'm going to touch on the availability factor of this one component. So we talked about vShield app, about vShield Manager, right? We think about that as an intricate piece of the cloud. You have to have it in place in order to proceed with your vCloud deployment. Now, when it comes to availability and making sure this manager is available, we tend to we provide certain ways, certain proven practices, may have been of even possibly recommending a configuration of some sort that even allowed you to use one of our technologies because it suited that particular application in terms of availability. For example, I'm talking about you can possibly use FT to protect the manager at some point. We always focus on trying to make things available. So I don't know if everyone got to see it this morning, if you're looking at the screen closely, where in the demonstration you saw how vShield Manager has now a new high availability feature, where depending on the sizing of that and what it could be done, it's now becomes where it deploys another VM to make the environment highly available, specifically to make sure maintain that if there's a failure of that one manager, there's something else that's available out there. So my point to that is this: you know, there are all these practices and best practices that are published, and as Duncan iterated before, things continue to change with the platforms, and as the products become, they start leveraging other technologies that we have within, and different use cases become available for them, things will change. So if you're too affinitized to a specific process, if you tend to always focus heavily on best practices, you may want to be a little bit more flexible, because obviously, you know, we're in a business that things change very rapidly. So it's really good to be able to have an adaptive sort of approach to most of your designs and architectures.
So everybody's we've mentioned a couple products, but is everybody familiar with the architecture of vShield? That there's a manager component that actually deploys the other components, or actually takes care of those for you. In my group discussions, I tend to talk a little bit about that as well, and what's kind of stored in that area as well. Can you talk, Duncan, a little bit about vShield app and Edge, just quickly, specifically where you would kind of position those considerations?
Yeah, first of all, vShield Edge. So vShield Edge, what we've seen is that it's often mostly used with vCloud Director, and one of the reasons for it being is that it's packaged together, right? So you don't have an option at that point. But if you look at what vShield Edge does, it literally is the edge device of your data center or the virtual data center in these cases. So vShield Edge does offer a lot of cool new enhancements. So Rawlinson just mentioned the HA feature that's part of vShield Edge. And that's probably one of the most requested features, and I've tested it out in my lab, and I think this is probably one of the coolest features of Edge as well. But on top of that, it will offer you things like DHCP, netting, firewalling. That's all parts of that Edge device itself. Now, if you compare that with vShield app, which kind of seems similar, vShield app actually takes a different approach than vShield Edge does. So vShield app allows you to do firewalling on a NIC level, so it's a per host-based type of firewalling. Now, this also means that from a implementation perspective, there's a slight change in behavior. So, for instance, with the previous version of vShield app, from a design consideration perspective, it was not recommended to protect your vCenter server. And the reason for that being is that vShield app adds a what we call a filter. So it adds a filter to the virtual machine, and as soon as that filter gets added to the vCenter server, the vCenter server was basically lost because it wouldn't be able to reach the network anymore. Now, with the latest version, we've solved those issues. So again, best practices and recommendations have changed.
So we got about 5 minutes left, I think, in the session. So the last topic, we touched on vShield Manager a little bit. So Duncan, can you talk a little bit about some of the new features in storage and where the considerations would be, as well as just what to think about?
Yeah, if you look at 5.0 was released, I think the biggest feature, in my opinion, is storage TRS. And in 4.1, storage I/O control. Unfortunately, not a lot of many people actually enabled storage I/O control, which kind of struck me, because especially in a cloud environment where the noisy neighbor problem can be a huge deal, because if there's a single virtual machine driving 15,000 IOPS, for instance, then all the other virtual machines running on that single one could be impacted by it. Now, using enhanced features like storage IO control, but also storage DRS, can help you avoid those problems.
So that kind of brings us to the end of the session. So we wanted to leave a little bit of time for questions if there are any. And of course, I want to thank the three panelists for putting this together. So if there are questions, I know there's mics in the aisles. I think they're the furthest away from anybody. So question up front, I can repeat it.
Okay. Just in general, follow up with Duncan. Out-of-box thinking. So everything we do, ultimately for the customer apps, right? More and more software goes to SaaS, including a service. The software comes with VM, comes with the cloud. So you don't need to worry about to do all those cloud. So what do you think about that growth?
So just to repeat the question, it was a great question, because we've been talking about how applications are really the big consideration, right? How does the app perform? How does the app work? The gentleman's question up front was, how does that actually start to play into software as a service, right? And how are we deploying that? And that's actually a great question. I don't know if any one of the four of us have a good answer yet. But it is really considering the apps.
Yeah, and it's a difficult question to answer as well. It all depends on the application itself. So SaaS solutions are really cool, but what I've seen in most enterprise organizations is that they got a massive amount of legacy applications, and these are usually forced by their specific vendors. And it's really difficult for them to tell the vendors to create some sort of SaaS solution. So although, in my opinion, it's the way of the future, and things like, for instance, new agile application architectures like the Spring Framework are definitely the way of the future, but reality is today that most vendors still produce legacy apps. We still see a lot of COBOL. I even still see 16-bit applications being virtualized, right? And that's actually one of the few times I've seen a real use case for a limit on a virtual machine, a 16-bit application.
I actually did, to address that as well, I had a customer who I got on a call with that is a software provider, right? So they're in the healthcare industry, and they wanted to package up their application and deliver it in their own cloud as software as a service, right? And then bill the customer for both the resources and the application. Because it's a great question, because what they were running into was they wanted to support it on VMware, and they would support their application on VMware only if they actually set up the VMware environment. Because what was happening is the hospitals or the customers were setting it up, and they couldn't guarantee the configuration to support the application. So now, with the advent of cloud applications and software as a service, they're saying, well, why don't we just host it? Why don't we become a service provider of our own application and turn it into software as a service? It's a great use case. You see that more and more. Some of us are already using it in some aspect. We don't even know it, right? If we're paying for an online version of an application versus the boxed one. And the best personal example I can give of that is QuickBooks. QuickBooks has an online.
The gentleman at the mic, do you have a question? Are you next to the mic?
Yeah, just wanted to know if auto deploy supports the hosts that participate in vCloud Director, or do they need to be prepared each time the host is rebooted?
Yeah, that's a good question. So the question is if hosts in vCloud Director actually would support auto deploy. So in my lab, for instance, I have that up and running. So what vCloud Director does is it installs an agent, and you can prepare auto deploy in such a way so that it will actually use that agent. Other agents, like for instance the networking agents, but also HA, which is just a regular VIP, which is a package, gets pre-installed. So you can actually use that. And I think especially for cloud environments, it's the easiest and probably fastest way to deploy new hosts. So from an agility perspective, it is definitely the way forward. Thanks.
We got probably 2 minutes if somebody else has one more question. Or actually over here, I think you were waiting.
So since Heartbeat doesn't protect the vCloud Director component, can you explain how it's still useful to protect vCenter?
We can. We should probably talk separately. We have an answer for it, but just for the sake of time, you can.
It's a short answer, though. So if you look at vCloud Director itself, it's a scale-out architecture. So it uses cells,
right?
And you can set up multiple cells. So
right, and we load balance.
You will need to protect the vCenter server, but B, you can also scale out VCD. So by setting up multiple cells, you actually solve that problem without the need for something like Heartbeat.
I guess I'm thinking more of the database component than the cells themselves.
Yeah, so what we see a lot is that people start doing database clustering.
Okay, so is that supported now with SQL
I
Server?
can't comment.
Yeah. See,
So
I was
you know the
hoping he was just digging, and I'm
He was
like,
setting
Duncan,
me
just
up.
stop talking, dude.
I was about to jump in space and dodge that bullet.
All right, on that note, I think we got about 30 seconds left. So I know you guys got other sessions to get to. Thank you to the panelists. Thank you to you guys.